Hello everyone, once again I welcome all the viewers to this online class that is conducted especially for the class 10 students. Today we are going to continue with the chapter Carbon and its compounds from chemistry textbook under the MBOSE syllabus. Let us begin. Last class we were discussing about the occurrence of carbons, and we are also discussing about the covalent bonds between some elements, between atoms of the same elements. Today we are going to continue on the covalent bonds but between atoms of different elements. And before that, let us recall again this element carbon. Carbon has atomic number 6 and mass number 12. So atomic number of carbon is equal to 6. This is equal to the number of protons. So this is the 6, the number of protons. And here, because there's no charge that is associated with this carbon, so this 6 is also equal to the number of electrons. So here the number of electrons is also 6. And this 12 is the mass number. When we say mass number, it means that it is the number of protons and neutrons. So mass number, which is equal to 12, the number of protons and neutrons. As there are 6 protons, so there will be 6 neutrons. So as there is 6 protons, so from here, because mass number is 12 is equal to number of protons plus number of neutrons, and number of protons is 12, so number of neutrons, as number of protons is 6, so number of neutrons is also 6. So carbon has 6 protons, 6 neutrons and 6 electrons. Now let's represent carbon in the Lewis dot structure. First of all, let us write the electronic configuration of carbon atom. It has atomic number 2, so the electronic configuration will be 2, and then it will be 4 to get 6. This will be the K shell, and this is the L shell. See, the outermost shell here is the L shell, and in the Lewis dot structure of carbon, is it has 6 electrons or 4 electrons in the outermost shell. So carbon on its own is unstable. For carbon to be stable, it has to have, if it is in the second order shell or more, it has to complete that octet structure. That is, it has to have 8 more electrons to have this outermost shell. It has to have 4 more electrons so that this outermost shell will have 8 electrons. Or the question also comes that, can carbon also lose these 4 electrons so that it will have only 2 electrons? And this electron, or this shell being the first order shell, so it will follow that duplet rule. So it will be stable if it loses these 4 electrons. But is that possible or not? So let us see about these two questions, whether they are possible or not for carbon to lose these 4 electrons so that it will have only 2 electrons, so that duplet structure will be completed, or is it possible for carbon to accept 4 more electrons so that this shell will have 8 electrons. So let's have a look at these two cases. Let me write here the electronic configuration of carbon. Electronic configuration of carbon 2, 4. Let's look at this first case. Carbon has 4 electrons in the outermost shell. So, can carbon lose these 4 electrons from the outermost shell, so that we'll have 2 electrons in the K shell, and because if there's no more electrons here, this will become the outermost shell. So, it will be stable if that is possible. So, suppose carbon, just carbon like this, it has six protons, and it also has 6 electrons. If carbon loses that 4 electrons from the valence shell, what will happen? Then carbon, it will lose all these 4 electrons. So protons, there will still be 6 protons. There will be, because it will lose 4 electrons, so there will be 2 more electrons. So electrons, there will be only 2. So in this case, 6 protons, 2 electrons. So the positive charge will dominate, and will dominate by 4. So this will become a cation, which is 4 plus C, 4 plus. This is a cation. So in this case, is this possible or not for carbon to lose its 4 valence electrons, so that it will have 2 electrons, and which is now the outermost shell? But in order to lose these 4 electrons, because protons and electrons, they attract each other, and the force of attraction is very strong, so it will require a huge amount of energy to remove these 4 electrons from the attractive pole of the 6 protons, and that is not possible. It is not practical. That's why this is not possible, because it will require a large amount of energy to pull the electrons from the attractive pole of the protons. So this case is not possible. So let's look at the other case where we can have 4 more electrons added to this carbon atom, so that this outermost shell will have that octet structure to be completed. Let's have a look at that case, number B. Suppose, if possible, carbon gain 4 more electrons. So if it gains 4 more electrons, this valence shell would contain 8 electrons. So in that case, carbon, it has 4 and 4 more. So protons, there are 6 protons, and 6 electrons plus 4 more will be 10 electrons. So in this case, the carbon atom would have this, the negative charge would be excess in this case, so it will be 4 minus. So this will be an anion. So is this case possible for carbon to gain 4 electrons? So in this case, they say that carbon atom has a very low electronegativity. That means it does not have the tendency to accept electrons. it is very hard for 6 protons to hold 10 electrons. That's why this case is also not practical. So that's why this is also not possible, because it is not possible for 6 protons to hold 10 electrons. So carbon can neither gain electrons, and in the previous case it cannot also lose electrons. So how do carbon form a bond with other elements? Carbon overcomes this problem by sharing of electrons. That is, it undergoes covalent bond with other elements. Now let's have a look at covalent bonds. Last class we were discussing about covalent bonds between atoms of the same elements. Now let's have a look about the covalent bonds between atoms of different elements. First of all, let's have a look at the formation of hydrogen chloride molecule. Which is HCl. In this case, we will do the same thing as we have done last class. First of all, we will write what is the atomic number of hydrogen. Atomic number of hydrogen is 1, and for chlorine the atomic number is 17. So the electronic configuration would be, electronic configuration for hydrogen will be only 1, which is the K shell, and it is the outermost shell, because there is only one shell. And here also the electronic configuration of chlorine is 2, then 8, and makes 10, so 17, so 7 more. So this is the K, L, and M shell. So in this case, because hydrogen and chlorine, they are non-metals, so they do not accept or gain electrons, so they undergo sharing of electrons. And because hydrogen has 1 electron in the outermost shell, so it needs to have 1 more electron to complete that duplex structure. So it will share only 1 electron. And because in covalent bond we have equal sharing of electrons, so chlorine also will have to share only 1 electron with hydrogen. So if we write in the Lewis dot structure, this the electron in outermost shell, and chlorine also these electrons in outermost shell, there are 7 of them. See, when they are close to each other, fluorine also has 7 electrons in outermost shell, so it needs 1 more. So hydrogen also has only 1, it needs 1 more. So both of them agrees to share 1 electron each, so that they would become stable as hydrogen chloride. So in this case, when they are close to each other, they would share these electrons. So hydrogen will share 1 electron, chlorine will share this 1 electron. So these 2 electrons will be shared between these 2 atoms. So in this case, this bond between hydrogen and chloride is hydrogen and chlorine is formed. So because there is only 1 electron pair that is shared between these 2 atoms, we can represent this by a single straight line. And let's have a look at one more, which is the formation of water molecule. Formation of, second one, formation of water molecule. Again, for hydrogen, we have, as before, atomic number and the electronic configuration. But for oxygen, the atomic number of oxygen is 8. So the electronic configuration would be 2 and 6 more to become 8. This is in the K shell. This is in the L shell. Here we have hydrogen. It needs 1 more electron, so that will become stable. And for oxygen in the outermost shell, it has 6 electrons. So it has to complete that octet rule. That is, it must have 2 more electrons, so that will have the electronic configuration of a stable gas element. So in this case, when there are 2 hydrogens, so we can represent like this: 1, 2, 3, 4, 5, 6. Hydrogen, it has only 1 electron. And let me write one more here. See, I write this separately, like this, not together with this, because hydrogen can share only 1 electron, and oxygen will also share 1 electron, so that there will be equal sharing in the covalent bond. So when they are close to each other, they will share this electron will share with this one, and this one from oxygen will be shared with this one from hydrogen. So in this case, this will become 1, 2, 3, 4, 1, 2, 3, 4. See, this electron will be shared, so this will be shared like this one as well. So in this case, oxygen will have 1, 2, 3, 4, 5, 6, 7, 8. Will have 8 electrons, and so hydrogen also will have 2 electrons. So the duplex structure for hydrogen and the octet structure for oxygen are completed. So in this case, we can also represent this as this. This is how water molecule is formed. So you can also try for some more molecules. You can also try for ammonia, carbon tetrachloride, methane, and carbon dioxide. And these molecules, we do the same way, but the electron pairs that will be shared will be in a different way, but it will be in the same manner. So in this case, now we will move on to some properties of covalent compounds. Now we will look at some properties of covalent compounds. First of all, we will note down this. First of all, we know that the forces of attraction between the molecules in the covalent compounds, they are called van der Waals forces, and they are weak forces. The force of attraction between the molecules in covalent compounds are very weak forces called van der Waals forces. So as a result of this, because the force that binds the molecules in a covalent compound, they are very weak forces, so in that case, that's why they have low melting point and boiling point, because small amount of energy is enough to break the molecules in a covalent bond. And again, as a result of this, they in the physical state, they mainly occur in the physical state. In the physical state, most of them are gases, and in the liquid, some of them are volatile liquids, and in the solid, they are very soft. So in solid, they are soft, solid. And again, because the force that bind these molecules are very weak, so they are not compact. So that's why they have low density. And then we have two more, because in the covalent compounds they are formed by sharing of electrons, so they do not dissolve into ions. So that's why they are insoluble in water. Again, because of the absence of ions, they are bad conductor of electricity. So these are a few properties from covalent compounds. We will stop till here. I hope you have understood. We will continue next time. For now, we will stop till here. Thank you.